Hello. Today we're going to talk about completing the squares some more and how to rewrite equations into vertex form. So the essential question today, how can I complete the square of a quadratic equation to put it into vertex form if the leading coefficient is not 1? So last week we concentrated on if the leading coefficient is 1, but now what if it's not? How are we going to take care of that? So in order to complete the square, the coefficient of x squared must be 1. In order to accomplish, or we can accomplish this in two different ways. We could either divide both sides of the equation by the coefficient of x, or we can factor the coefficient of x squared once the constant is moved to the other side. Those are our options. Either divide both sides by the equation, or of the equation by the coefficient of x squared, or we can factor after we move the constant to the other side. So let's see some examples of this in both different ways. The first way, I'm going to divide both sides by the leading coefficient of x. And when I divide everything, or when I divide both sides by 2, I'm going to make sure I divide everything by 2. Once I divide everything by 2, I'm going to move the constant to the left side, just like last week, and then I'm going to have to figure out, okay, what completes the square? So -6 divided by 2, and then square it. We're looking at, okay, -3 squared. I'm adding 9 on both sides, and then I'm simplifying the left side and completing, or writing the completed square on the right side. So once we have the completed square, we're going to move the 4 to the other side. We're almost in vertex form. And now we have to get rid of this division of 2 that we did in the beginning. So now we're going to then multiply everything by 2. But when I say multiply everything by 2, when I multiply the left side by 2, it undoes this division of 2. When I multiply this right side by 2, I'm going to have a 2 as a coefficient here. And then I'm also going to multiply this term by 2. I had to shrink my work in order to have some more room. So I'm going to multiply everything by 2. Now I have y equals 2 times the quantity x minus 3 squared minus 8. This is the answer for the vertex form. And then I'm going to make sure, okay, so the vertex is the opposite of what's inside parentheses, 3. And then I'm going to keep what's in the k position as the y coordinate. The vertex is 3, -8. So moving on over to the right side, what if the first step would be get 10 to the other side. So we have y minus 10 equals 2x squared minus 12x. And now, after you move the constant to the left side, we're going to factor a 2 out of the right side. So we have 2 times the quantity, x squared minus 6x. Again, we've got to ask ourselves, now that we have a leading coefficient of 1, I can figure out, okay, this linear coefficient divided by 2 squared is going to be a 9. So what happens is, I'm supposed to add 9 on the right side and the left side, but the bad thing is, technically, in this form, I add 9 inside parentheses, but that's not the actual amount that's being added on this side. Notice how I have to include that factor of 2. Technically, I'm adding 18 because you have to consider 2 times 9 is 18. So if I'm adding 18 on this side, I also have to add 18 on that side. Now we're going to clean up. We're going to rewrite in the completed square form and subtract 8 to have the completed square form. Again, the vertex is still opposite of 3, or opposite of -3, so we have vertex being 3, -8. So onto this side, we will only do those new rules if I have a leading coefficient that is not 1. So notice how in this example I do have a coefficient of 1. So I'm going to figure out, all right, what is -6 divided by 2 and squared? Well, it's that 9 that we got from the previous one. So I'm going to add 9 to both sides. Then I'm going to simplify the left side if needed, but it's not needed this time because I also didn't have a constant I needed to move over in the beginning. There was no constant. And rewrite the right side as a completed square, vertex form, x minus 3 quantity squared minus 9. So the vertex is going to be 3, negative 9. Both of those are my answers because it says write the quadratic function in vertex form. There it is in vertex form. And then identify the vertex. That's what we're going to need for the second part of this chapter. Moving on to the next one. In this case, I actually do have a constant. So let's move the constant to the other side because notice how I have a coefficient of 1. Now we're going to have to figure out, okay, 4 divided by 2 and then squared. We're looking at 4. Clean up the left side. Rewrite the right side. And get it in vertex form. Vertex is going to be negative 2, negative 7. Notice how it's the opposite of what's in the H position, but the position of K keeps its sign. Or the X coordinate switches the sign, the Y coordinate stays. So I notice that I've got a leading coefficient that is negative 2 and it's not 1. So I have two choices, either divide everything by negative 2 or factor a negative 2 after I move the constant to the other side. This is where okay, so what choice would be better? If I realize, okay, this would be y over negative 2, this would become clean if I divided it by negative 2. This is also divisible by negative 2, but this would become a fraction. If I have to deal with a fraction, I'm going to choose the other route, where I'm going to move the constant first and then factor a negative 2. So now I'm going to factor negative 2. Now that I have a 1 as a coefficient, I'm going to try to figure out negative 6 divided by 2 squared. We're looking at that 9. So I'm going to add 9 on this side, or add 9 in parentheses on this side, but we got to make sure, wait a second, technically I'm not adding 9 on this side because I've got a factor. Technically we're adding, well, negative 2 times 9. We're adding in a negative 18 on this side, so I'm going to add in a negative 18. Adding a negative 18 is the same as subtracting 18. Now we're ready to clean up the left side and rewrite the right side and rewrite in vertex form. So y equals negative 2 times x minus 3 squared plus 1. So vertex, now that it's in vertex form, that vertex is going to be positive 3, 1. So in example 5, I've got to figure out, all right, if I divided everything by 1/2, wait, dividing by 1/2, that is the same as multiplying everything by 2. If I multiplied everything by 2, well, there would not be any fractions. So if I can multiply through by something, I'm going to do that first to get rid of that fraction, to get rid of that leading coefficient. So multiply everything by 2. Now that I've multiplied everything by 2, I'm going to get that constant to the left side. And still notice how the purpose of, wait a second, why did we multiply by 2 all the way through? We got rid of that leading coefficient of 1/2, and now we have a 1, which we can complete the square. We can ask ourselves now, 8 divided by 2 squared is what number? That's what we're going to add on both sides. I'll clean up the left side, write the perfect binomial squared on the left side. Oops, I have a typo. Hold on a second. That should be y plus 6. And now solve for y, get it in vertex form. We've got y equals the quantity. Oh, wait a second, time out. So I corrected my mistake and didn't put 2y. So now we have 2y equals quantity of x plus 4 squared minus 6. But in order to get y by itself, I need to divide everything by 2. But the way we do that is, wait, dividing by 2 is the same as multiplying by 1/2. If I multiplied this by 1/2, this by 1/2, and this by 1/2, we can get rid of this coefficient. When we multiply that binomial squared by 1/2, we leave it as a coefficient, as a factor. When we multiply negative 6 by 1/2, we get -3. So there we have it in vertex form, but the vertex is going to be -4, -3. So let's talk about homework. So we've got the same stuff from last Friday, or Thursday, page 287, 56, 55, 59, 73, 74, 75. We've got to recognize 55, 56, and 59 all talk about solve. I need you to solve the equation by completing the square. So we're going to get x squared in the x term on one side and solve by getting it in a completed square. So get the constant to the other side. Now figure out, take the linear term divided by 2 and square it. All right, see you tomorrow.